Introduction to Elastic and Plastic Deformation. Click and drag the needle to prick the balloon in A. What happens to the balloon? Now, click and drag the needle to prick the balloon at the top in B. What happens to the balloon? Click and drag the needle from the balloon. What happens? Try this out using an actual balloon. When the balloon is pricked at the top, the needle goes through the rubber of the balloon without the balloon bursting. Whereas, when pricked at the side, the balloon bursts. The rubber at the top of the balloon is not fully stretched. It is still elastic and regains its original dimensions when the needle is removed. The sides of the balloon had been stretched beyond its elastic limit. When the needle pricks it, the rubber is stretched further and the balloon bursts. In this lesson, you will be able to learn to distinguish between elastic deformation and plastic deformation, learn to explain the elastic and plastic behavior of materials, distinguish the shapes of force extension graph for ductile, brittle and polymeric materials, learn to derive the formula for strain energy in a stretched wire, and learn to calculate strain energy from the FE graph and from the stress-strain graph. Elastic deformation. Searle's apparatus is used to study the elastic deformation of a piece of steel wire. Click and drag the slider down to increase the longitudinal force on the steel wire. Drag the slider for every increment of 5 Newton. Observe the scale reading and the extension of the wire. On the graph of extension against force, observe how the extension varies with increasing longitudinal force. Now, reduce the force on the wire by sliding the slider slowly upwards. Observe how the extension varies on the graph. Does the wire regain its original length? Answer: yes. The wire is said to undergo elastic deformation because it regains its original length when the force on it is removed. When a wire undergoes elastic deformation, extension is directly proportional to the force. Hence, Hooke's law is obeyed. Stress is directly proportional to the strain, and stress over strain equals Young's modulus of the material of the wire. The extension force graph and stress-strain graph are as shown. What happens to the atoms in a metal when a wire undergoes elastic deformation? Click on the wire to observe the arrangement of atoms in the wire before it is stretched. How are the atoms arranged? Answer: the atoms are arranged orderly in atomic planes. Now, click at the end P of the wire to stretch the wire within its elastic limit. Click on the wire to observe the atoms in the wire when the wire undergoes elastic deformation. What happens to the atoms when the wire is stretched? Answer: the separation between the atoms increases. Click on the end P again to remove the force F, stretching the wire, and observe carefully the movement of the planes of atom in the metal. Summary. When a wire undergoes elastic deformation, extension is directly proportional to the force. Hence, Hooke's law is obeyed. Stress is directly proportional to the strain. Stress over strain equals Young's modulus of the material of the wire. Click increase repeatedly until the extension stops. Observe the extension force graph being drawn. Does the wire still obey Hooke's law beyond the point A, which is known as the limit of proportionality? Answer: no, because extension is no longer directly proportional to the force. The extension force graph is no longer straight. Now, unload the wire by clicking decrease. At the same time, observe the extension force graph being drawn. Does the wire regain its original length? Answer: no, there is a permanent extension after the load had been removed. The wire is said to undergo plastic deformation because it does not regain completely its original length after the longitudinal force on it is removed. Click Extension Force Graph to observe the extension force graph being drawn as the longitudinal force on the wire is increased until the wire breaks. Click on the points A, B, C and D to know the name given to each point in the deformation of the wire. Click on the wire to observe the atoms in the wire during plastic deformation. Click on the end P to stretch the wire beyond the yield point. Observe the sliding of the atomic planes due to the movement of the dislocation. Click on the end P again to remove the force F. Observe the atoms in the wire. Do the atoms return to the initial positions? Answer: no. Does the wire regain completely its original length? Answer: no. Summary. In plastic deformation, the wire does not regain completely its original length. Permanent extension is produced. Atomic planes slide over each other due to the movement of dislocations.